Hi there, folks, and welcome to another one of our interview videos today. We're joined by Dr. Judith Hubbard and Dr. Kyle Bradley. They are earthquake scientists or seismologists. They are also visiting scientists at Cornell University. They also run a great Substack newsletter, Earthquake Insights. We'll talk more about that with our time with them this morning. But first of all, just Judith and Kyle, thanks for joining us today. We appreciate it.
Yeah, no problem. Thanks for having us.
Yeah.
Oh, awesome. So yeah, I'd just like to start with people's backgrounds. I mean, I reached out to you via email. This is our first time really meeting. And so maybe just share with us a little bit about how you guys both got interested in science and kind of those early years as you were kind of like going into this field.
It's kind of funny because I could speak or he could speak and it would be almost the same story. Kyle and I met freshman year at Caltech, and we were not geology majors at that point, but we took our first geology class at the end of freshman year, and we both decided to switch out of our respective majors into geology, and since then we've been studying geology together.
Were you both from California or?
No, I'm from New York and he's from Colorado.
Okay.
Yeah.
Okay, go ahead, Kyle.
Yeah, I grew up in Southwest Colorado, so Cortez, Colorado native. So I was always surrounded by a lot of geology, but I never really understood or appreciated it. I liked the landscapes. I liked being out in nature. But I never really understood kind of the world of geology until I took this class. You know, we went on a field trip to the Eastern Sierra. I recall very vividly one of our professors, two of our professors, John Eiler and Ken Farley, invited a group of students to go in a van up to Whitney Portal to collect cosmogenic nuclide samples or something, just off the cuff. And Judith and I both volunteered. We went up there and saw these geologists like diving into mountain rivers, wresting rocks from the ground to understand how fast the mountains had gone up. And it was just like, well, we're geologists now. So
I remember being at the top of the mountain, and I also remember the drive up the mountain because it's a very windy road along the side of the mountain. There's a lot of cliffs. And there's one cliff on one side of the road that goes up and one side that goes down. And I was looking out the window at the downside, but the professor who was driving the vehicle was looking at the upside to see all the rocks, which since then I've been that person, but at the time it felt fully responsible.
Right. So, you know, after undergrad, we both still love geology. We tried to figure out what to do for grad school. We ended up splitting to two different schools because it's important to differentiate. So Judith went to Harvard and I went to MIT. I was just enchanted by field geology. My geological field mapping courses, you know, were just so eye-opening to me. I wanted to continue that. So I worked on a PhD project in doing field work in Greece, kind of looking at the tectonics of the Aegean region over the last 15 million years. It involved a lot of stuff like stratigraphy, paleomagnetism, mapping, all kinds of things, and very little about earthquakes, despite standing on these active faults.
Right.
Very little about earthquakes.
And I was, you know, back in the computer lab, I was using seismic data to look at faults associated with the Tibetan Plateau. I was trying to figure out how the Tibetan Plateau had grown on its eastern edge, looking at the fault record. And then in 2008, there was this really big earthquake right in the area where I'd been looking at all of these faults. And so that's when I started to think about this relationship between this long history of geology and how active and hazardous and societally relevant it can be, which is what sort of pushed me into my later career track of looking at fault geometries and the relationship to earthquakes.
Right.
Yeah.
Right. So a little bit different disciplines, it sounds like, for each of you. Judith was definitely a little more like earthquake focused and political side. Kyle was a little bit more maybe broad-based, structural geology, field mapping, that sort of thing. Nice compliments, though. I mean, those go hand in hand together for sure. Did you work on any projects together? Or was that always kind of like your own separate areas? Or, I mean, at least in those early kind of grad school days?
In the grad school days, no, we didn't work together at all. I would go over to Harvard for the parties because they had really great
right.
And some interesting people to talk to. But no, we didn't work together on things. We talked about things, you know, our field are in parallel. So we talked about things.
Okay, I went to Greece one
that's right.
time as a field assistant
There we go.
to take advantage of the ability to go and look at things. So that was
free trip
maybe
to Greece seems to be appropriate there. Yeah.
Great food and some great rocks.
I had a lot of field assistants over the years, and these poor students, I would get them from the MIT field camp. I would ask a student who did well in the field to come to Greece. If any of them see this, they'll understand. And I think a lot of them thought, oh, wow, Greece, beautiful beaches, beautiful weather, it's going to be amazing. And then all the time we're like scrambling through thorn bushes, looking for the most obscure rock outcrop possible for 6 weeks. Then we go home. So it wasn't the same level of
kind of dashed their hopes there. Yeah.
No, a lot of them went into geology,
Okay, so it didn't dissuade any of them.
Yeah, they loved it.
Were you? Go ahead. Sorry, Judith. No, you go ahead.
Oh, when we graduated from our PhDs, we were looking around to try to figure out what kind of jobs were available. And it turned out that one of our old professors from Caltech had gotten a huge grant in Singapore to start a research institute on earth hazards. So we applied to jobs and we got jobs there, and we picked up from Boston with our 1-year-old kid and flew across the world to the other side of the world.
Wow.
And started new jobs focused on earth hazards. So that was pretty exciting.
Yeah. So like all the way to Singapore, right? That's quite the move for you.
Long trip.
Yeah.
Yeah. What was the work like there? What were you doing there? Like, what was the main kind of thrust of the work?
The Earth Observatory of Singapore was founded by Kerry after the 2004 Sumatra Andaman earthquake. And Singapore realized that they needed to have better capacity understanding these regional disaster things that could happen. And so the Institute was founded to raise the capacity in Singapore, but also in the region of Southeast Asia for earth hazards, mainly earthquakes, volcanoes, tsunamis, things like that. And so it was a really young interdisciplinary group of risk-taking scientists working in an area where a lot of work had kind of been done patchily, but has to some degree been ignored scientifically. And so there are a lot of broad open vistas. And I think everybody who went there suddenly had to kind of change what they were doing. You couldn't just continue your previous research, even though, like if you worked on the faults of California, well, that's great. But now you're working on faults in Southeast Asia. And it's a very different process there. The systems are different, the governments are different, societies are different. A lot of people had to retool, refocus. I, for instance, stopped doing so much field mapping, very little long-term geological mapping, focusing more on active fault systems and how they interact with other systems. And so it was this really great integrative opportunity to look at things for the first time. And there was a lot of money, right? So there was a lot of opportunity to kind of do what you wanted.
It was almost like if you could dream it up, then you could get money to do it. And we were more constrained by people and hours and logistics than we were by money, which was an experience. I think it's challenging, but it's so rewarding to be able to just imagine the science and then make it happen.
Yeah, kind of carte blanche in terms of research. Like, hey, we've got whatever you want to go after, as long as it's related to earthquakes and it's going to help our country and long-term goals they have.
Right.
Yeah, so Judith asked for and received a Vibra-sized truck, like a mini buggy.
Oh yeah,
and
the thumper trucks. Yeah,
like a real one, a small one. And we went to Oklahoma, and she like picked it out and did all this stuff, and then she took it to Nepal and ran all these seismic lines across the main frontal thrust of the Himalayan fault system there to discover the geometries of these faults. And that's the kind of project. It's just out of this world.
Pie in the sky kind of tech.
Yeah.
I mean, it's wild.
A lot of times it paid off really well, I think, that kind of risk-taking scientific approach. And this kind of comes back to this whole story. Like, why was I successful in my research in Southeast Asia? It's largely my geological background that I gained, in America and in Europe. This foundation of geology is really important for studying active systems. And so if you come from a background like that, and then you transition into, hazards or earthquakes or other kinds of things that are in the present day, I think it provides a lot of important perspective and like new ways of attacking problems.
Right.
So we both ended up, we have an earthquake blog now, right? We read about earthquakes. And when you introduced us, you said we were seismologists, but we're not seismologists.
Oh, I didn't.
Yeah, people don't know the difference. A seismologist, is somebody who really looks at the wiggles, right, and uses math and their understanding of things to infer what's going on in the earth. But we're really geologists, right?
Yeah, I
and
guess
so we
I
let.
thought about that, but yeah, a seismologist more of a geophysicist, I suppose, opposed to an earthquake scientist, as I think you label yourselves, which is looking more at the mechanics and and the real like the ground data, I suppose, the fault systems.
I think earthquake scientist is a really broad term. A seismologist is an earthquake scientist.
Sometimes, yeah.
And a paleoseismologist is an earthquake scientist. And somebody who studies the effects of earthquakes on, like liquefaction is an earthquake scientist. So there's lots of different ways to be earthquake scientists. And in our work, we kind of try to grab little bits of everything, because that's really what makes it the most interesting.
Yeah. No, I've never thought of that before. That was very educational for me, because I just thought, oh, you study earthquakes, you're a seismologist. But I mean, you're absolutely right that, they're studying the seismograms, the actual energy waves of the earthquake coming through.
Yeah. And for a long time, seismology was the only earthquake science, really. I mean, seismology is such an old discipline, going back to the late 1800s. These early seismometers, they recorded, the San Francisco earthquake, right, in 1906. And so it's the first remote sensing technique ever invented, where you can actually see what's happening inside the earth or across the surface of the earth, using only an instrument recording the motion of the ground. And so not to underplay seismology, but I don't look at, well, usually I'm not looking at seismograms. I'm not running the codes and doing all the things that seismologists typically do. So I don't call myself a seismologist, but I read what they do and I pay attention to what they do.
Yeah, because you got to integrate all that data when you're kind of studying these systems. You need to understand.
And the first data we get is always from seismology, right? Yeah. The first notification on our phone, there was a big earthquake. That's from the seismologists.
Yeah.
Yeah. No, that was actually really illuminating for me. Thank you for I just naively just thought, oh, seismology, they study earthquakes, volcanologists study volcanoes. But it's there's more nuances to it than that, for sure.
So the other thing we did in Singapore was the university asked the Earth Observatory of Singapore to start the first academic program in geology in Singapore, because Singapore did not have a geology program at the time. So we got to be part of that, starting the grad program and the undergrad program in geology, which is, I think, pretty unique. These days you see programs shutting down more than you see them starting up. Yeah. So that was pretty special to get to figure out how to
building it from the ground up. That's what you guys were doing, like just starting from
the first cohort. We were doing only first year classes.
Wow.
Then the second cohort, you sort of build the program as it goes and figure out who's going to teach what courses are important. How do you engage with students and get them to where we think they should be?
Right.
What are their jobs going to look like in Singapore?
That's a challenge for sure. Wow, that's impressive. And that was just like a full bachelor's program that you built, like with all the mineralogy and like all the typical subdisciplines and.
Well, there were some holes, like a small department. So there were a lot of people involved in this process. Yeah. It's not just geoscience. It was also, it's kind of a earth system science program, right? But it had a pretty good geology cohort. So there were a few holes here and there, right? Like optical mineralogy, those kinds of classes were pretty minor. But we had, good intro geology courses, good structure. We had a lot of field experiences for the students.
GIS.
I had a class that I taught. We would take the student for 5 weeks to California and camp and do field mapping for 5 weeks. The classic kind of exposure to the earth. Yeah, yeah. And so everybody had to work together to build something up and get it to run. And at first you have only a few students, and then the cohorts grow, and it's really interesting
Yeah, probably really
experience.
satisfying to kind of see it go from, not necessarily nothing, but not much, and then like watch it build and grow. Because I'm assuming that program's still in place today, and it's well, and
And then there's some of the students who are off at grad programs,
right.
getting their PhD. So we'll see sort of where that takes them and what impact they have. I think some of them are planning to return to Singapore and be part of the system. So some long-term impacts, I hope.
How many
Yeah,
years were you in Singapore then?
about 10 years,
Yeah.
a little less than 10 years.
Yeah.
Yeah.
And then what was the next move? What was caused the next transition in your career?
Well, then we just quit our jobs and moved back to America. So I mean, we could go into the details, but basically after COVID, we got locked down in Singapore for like 2 years. We
Yeah.
couldn't leave the country, and we realized at that time that our kids were growing up. It's a wonderful place. It's a wonderful place to have kids too, but they weren't growing up kind of the way we wanted them to be growing up. This, like I talk about, my exposure to nature is a big part of my upbringing and like my who I am now.
Mm-hmm.
And we just didn't have that. And we were so far from family, and those kind of things just piled on over time. And so and our kids were having health problems from the tropical environment. And so
Right.
we had to bail.
Yeah.
And it's not like you can just parachute out into two faculty jobs somewhere else.
Right.
And so, we were burned out to some degree, I think. And so we came here. We actually bought Judith's parents' house, which she grew up in Ithaca, which is a beautiful place to raise kids too. And then we took a break, and then we asked ourselves, what do we want to do? Like, what do we really enjoy? What is important to us,
Right.
right?
And we knew we wanted to have we didn't necessarily want to go straight into full-time jobs, even if that were an option. We wanted to be able to do something that felt meaningful.
Mm-hmm.
And then these big earthquakes happened in Turkey. And it was 2023, February 6th. It was 7.8, and then there was a 7.5, I think 9 hours later. And I'm sure all your viewers know about these earthquakes in Turkey. They killed about 60,000 people. There was images of building collapses. And from a geological side, a really sort of a story that's been told now in a lot of scientific papers about the rupture of this fault that people knew about, but they didn't really know it could have an earthquake this big. The triggering was unexpected. It was onto a different fault. And then what I found was, I was already on Twitter at the time. There were a lot of people in Turkey. I'd always imagined that after an earthquake, the story ends because the big earthquake already happens, that the geologists have had their say in advance. You found the fault, you talked about the hazard, and the earthquake happened, and you move on to the non-geological side.
Mm-hmm.
But the people in Turkey were wondering what was going to happen next. Now, you can't predict an earthquake, but you can talk about things like aftershock patterns, right? And you can explain why things happened the way they did, and what this thing that people are seeing meant and why that happened. There was a really big audience, it turned out, of people who were impacted or people who were living abroad whose families were impacted.
But you were using Twitter to help communicate, especially those people affected in Turkey, kind of what was going on, giving them some clarity to the chaos that was. I found that's two instances in my own life as well. That's like huge. Like that's people want answers. They want to know, okay, maybe we can't predict things, but like, why is this happening? What's the typical scenario? And just, I think people knowing that this is normal, that there's, at least this is a natural process, and that these things are, I think that's comforting to people, like, and giving them that knowledge, I think is empowering. You find that as
Yeah, that's exactly what I found, was that even if you don't have good news for people, just knowledge can help.
right.
Right. And you don't want to cover up, the chance that more earthquakes could happen. They want to be able to trust you. So even if the information you say is uncertain, you don't know if there will be a triggered earthquake, you don't know when the next big aftershock will happen. the fact that somebody is there who's listening and who's communicating seems to be really helpful. And I think for both of us, that was kind of a turning point when we were trying to figure out what could we do with our skills that was impactful. It felt like that was something that we could do.
Right. So this was kind of your first foray, or at least significant foray, I suppose, into like outreach. And did you find that it was hard to relay that technical scientific information to people in a way that was understandable, or did that come naturally to you? I mean, because you guys are PhDs, you've been trained in the system, as I call it, where we're trained to speak technically, write technically, think on a certain level. And some people that get so deep in the research realm of their career, it's hard for them to pivot back, like communicating at a level that people can understand.
It can be hard. I think both of us had dabbled a bit with this before. We worked on blog posts together. I wrote some and self-published some children's books about geology, and I've been on Twitter for a while, so we explored that space.
I also think the time that we had at the Earth Observatory of Singapore, I think in many people there really took the mission of the institution to heart, which is it's not just about doing great science. You can do great science anywhere. It's about having impacts. And when we moved there and we suddenly were in direct contact with all these different people, I mean, from many different backgrounds, many different expectations, many different levels of understanding of the Earth system. And it was very important to us, I think, to try to figure out how to engage across all these different levels in different contexts. I remember, I've been out in the field on the Sumatran fault, like talking to people living on the trace of the fault, right? Who may not even know how earthquakes happen or that faults exist. We also talked to, government agencies who are tremendous experts in their local, hazard situation, right? You have to learn kind of how to interact on in these different dimensions, because you really do want to make your research have a bigger impact. And so I think we were kind of prepared in some ways from that experience of not just talking about only the detailed science. Oh, here's my great research result. Here's my new technique, anything like that. But really talking about the system itself and talking to the people who are, experiencing it. Yeah.
I think that's a trend that I think you guys are maybe trailblazing and innovating, along with others, I'm sure as well. But it's important is that the research is important, the science is important, but the old school method of just, we do peer review journals, and that information just stays at that level and doesn't really get disseminated widely, is just not very productive. So I think game changer is being take that and then go to those stakeholders and those people affected, like you guys are. It sounds like this Turkey series of quakes, was this kind of like an inflection point and like, wow, this is really making a difference, and you guys in the moment kind of sensed this was an audience and a market for your earthquake perspectives to be.
Yeah, and it was also, I think, a bit of an inflection point, at least I think for both of us, which is how interesting earthquakes really are. Not the rupture itself necessarily, but I just gave a seminar up at Cornell to students about this, and it was about the most interesting earthquakes of 2025. Okay, so there are a lot every year.
Mm-hmm.
How do you decide what are the most interesting? Well, then you have to answer this question: what makes an earthquake interesting, actually, to me or to somebody else? And there are so many dimensions involved. There's history, there's societal impacts,
Context,
there's the actual sciences, there's geology, right? Like earthquakes are a great way to look at the world because your attention is drawn to some place that you've never seen anything like it before, and suddenly there you are, you're looking at it and you can study it or understand it. And so for me, like when that earthquake happened and then a few others afterwards, I was just really drawn into this much more than I previously had been when I did research on earthquakes. I was working on, I'm crushing my kitten here. I was working on specific fault systems, looking at them in great detail. I cared a lot about my research. And over time, I think I found my work less and less interesting. As I got better and better at it, I found it less and less interesting. I guess I have a personality where I really want to learn all the time. I really want to be exposed to new things. I want things to be interesting. And so with those earthquakes, as you start writing about them, I mean, one earthquake communication strategy is I'm going to only talk about the impact on people. I'm going to talk about the things that the news organizations want to know. They want to know, what are the aftershocks rate? What is this? What is that about the earthquake itself? And what you find is you just repeat yourself over and over, which is a useful service to provide, but it's not that fun, and it's really not that
limited,
interesting. Yeah, I mean, personally, so we do some of that, but I think also we really started kind of expanding our reach and expanding our scope when we started including things like historical stories or regional, points of regional interest, or the geology of different regions, or things like that are tied to the earthquake in some way, but the story would never be told, if you're on the news, the nightly news or something.
Right.
Yeah.
And then I think the other thing about earthquakes is, I think for the public, science is often told as stories that are completed, right? The researchers wanted to know something or wanted to know how to do something. They figured it out, and look at this amazing accomplishment. But with earthquakes, it's a real opportunity every time to answer new questions, because nobody has looked at that earthquake before, right? The earthquake literally just happened. And so you start with these questions, knowing the answers are not yet known. And you can figure out, how am I going to answer those questions? What questions do I even have? And for us, writing the post, we get to have that moment every time. And so we try to, I think that comes across when we write about them, is that we're going through the process of discovery, and people can do that, right? Everybody can do that.
Yeah, no, I 100% agree that definitely comes across when I'm reading your guys' posts. One, I feel like I'm learning, I'm being educated from someone that knows more than I do, and that's great. But I also do get the sense that you guys are on this path of just, hey, here's the stuff we know, and you're very forthright with like, here's what we don't know, and you're also welcoming to, like, you even put in your post like, here's what we think's going on, but we're not sure, and we'd welcome any other insights. And so it's not an authoritative, this is exactly a matter of fact happening, but it's here's our analysis, here's what we see happening, and here's some unknowns, and here's some holes in our knowledge that it could be filled. So it's very, the humility is there, which is appreciated and I think refreshing. And so with that, I have so many questions about this. So your earthquake insights, and I'll make sure we put a link to this in the description, and I could even pull it up if we want to share or whatever. But so for viewers, real quick here, Kyle and Judith put together this called the Substack. That's just the platform it's on, but it's basically a newsletter. So whenever there's a significant earthquake that happens, or one that they feel compelled to share information with, they put together a written narrative with graphics, photos if they have them, and such. That gets blasted out. You can subscribe, and then you get that just in your email inbox if you want to. But they also have, and you guys can talk about this in a second, I suppose, but there's ways, if you're a student or you're using it for teaching purposes, you can access that information. So it's not, description isn't the end all be all, but it comes through so quickly. I'm curious as to your methods, like, because sometimes the earthquake's just a few tens of, maybe an hour old, and I'm trying to put together something because I have viewers who want my opinions on earthquakes, and I'm not an earthquake scientist. I'm a structural geologist, so I can show them the beach ball and look at a tectonic map and do some kind of broad inferences. But what's your process like when there's an earthquake? Like, what does the bat alarm go off in the house and like you guys scramble to your stations, or what happens?
Oh yeah, first about the website, right? First about the subscriptions. We publish everything for free for 30 days. We're absolutely committed that if you're following us, you shouldn't have to pay for what our information is, right? People around the world should just be able to get it. So then after 30 days, posts fall behind the paywall, right? And then people who have the subscription get access to all of that stuff. And yes, we have lots of, we will very happily provide subscriptions to people who cannot pay. And we do this pretty commonly. We don't want it to be limited, right? But we do want to make some living, right, off of what we're doing.
That's a lot of
It's
work
important.
and energy.
It's important that it be sustainable. Otherwise, we'll quit and it'll all go away, right? Like if we can't do it, it'll go away. So we really appreciate the people who have subscribed. It makes a huge difference when people pay for the subscription, but everything we put out goes free for 30 days because we just don't want to paywall information, especially in the period after an earthquake, right? When people really want to know. So what happens is we just monitor our emails. We subscribe to the USGS alerts. We have different alert levels set. We don't view ourselves as a rapid response kind of thing. Like I know people say we get stuff out fast, but by the time we find out that an earthquake's happened and we go online, like the LA Times or someone will already have like a news story about this up way before we start writing. We will do a quick assessment, on whether it's something that's interesting enough to go after. And then I guess we've developed some kind of a workflow between the two of us where we split responsibilities. And we're always asking, like, what is the story that we want to look at for this earthquake? What do we want to discover about this earthquake? So going all the way back kind of a few years, I've been trying to automate as much of my workflow as possible because like you say, like going and downloading data, making visualizations, doing all of this stuff is really time consuming and it's error prone. And so I've automated a huge amount of our back end, originally in probably some of the shadiest code ever written. But now I don't even, it was embarrassing to talk about it, but I started doing it and then like it snowballed. So now I'm like going back and rewriting things in like a more modern framework, but we still use the old code that for most of our posts. And the idea is if you want to make a map of, let's just say one of our earthquake maps, and you want to have all these elements on the map and you want to do it quickly, like how do you do that? And so the code I've written, you basically just tell it what you want. You say it's a command line code, and every map we make, every figure we make, basically is a line on a command line, like one command, and you basically tell it, I want a map in this region with this projection, with this kind of topographic base map with this kind of data visualized in this kind of way, and you add all these different options. And then you hit enter and the thing goes chug, 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 and it pops out a PDF, which is the finalized figure after 30 seconds or a minute. Now, there's a lot of stuff that goes into that back end, right? But all of that time and effort that I put into that over the past years pays off when you need to iterate a map. We taught GIS for years together, actually. So we're very familiar with lots of GIS platforms. And anytime you have to click on something, it's a roadblock to making something quickly and accurately and repeatably. Anytime you have to click on a menu or select something or drag it, like this is a roadblock. So we use a software called GMT, which is this old geophysics software for making figures. And I've just tried to knock down the barriers to making it work year after year.
So for instance, one of the biggest roadblocks for me was always getting the data, right? You want to make a map of earthquakes, you have to get the earthquakes first.
Yeah.
There's different places you can get earthquake data. There's, regular earthquakes, there's focal mechanisms, finding those is going to be harder. You download it, try to reformat it, try to load it into a software. It could take a long time. And then by the time you get around making the map, your data is not up to date anymore, right? Because now you have to go and download the latest earthquakes. So with this software, it's a simple command line to go and scrape all of the different sources of earthquake data and load them into my computer and add them to the collection so that when I run the command to make the map, it's taking that latest earthquake data from all of the sources, in a single file. So that's about several days of savings for making a map just on its own.
Yeah, no, you guys have automated that so that you can put together a map. And earthquakes are going to happen for the most part. The earthquakes are going to happen places where we've had earthquakes in the past and plate boundaries, and so at some point you can be like, oh, like we have that map, and probably gets eaten.
Yeah, and I go back to like the field geology aspect of this. When I was a practicing field geologist, when you're in the field and you have a question, you go and find the answer, right? You walk over and you find the answer. And so map making for me has always been basically that same process. How do you ask the question and find the answer that you're interested in from the data that you have, right? And so while I talk about the software as like a mapping software, what it really is an answer finding software, right? And it's a storytelling software. Um, so the maps that we put out, we don't have like a set visualization. We often do things the same way a lot of the time, but we're always looking for kind of like what is that angle of storytelling? And if a lot of times like we don't have that, and I'll have to go back and code something new and try it out for a while. And Judith's writing the article, and I'm doing that back end work. Um, and so I've actually used this software for teaching before. I had a global tectonics class where students would make all this kind of stuff. Hopefully in the future we'll be able to release, something that people will be able to use. It's a long-term goal. But there's dangers of releasing things that automate the scientific process, right? Enabling garbage in, garbage out is not high on my list. Like enabling that, especially as relates to earthquakes and other kind of like critical public health related things.
Yeah, you want
So
the
I'm
quality control to be there.
Yeah, and I don't want to become a tech support person, right? Like especially my own awful code.
And then every now and then we find errors in the catalogs,
Yeah.
which might. There was one large earthquake where we thought there'd been a large foreshock because it was in the catalog, but we realized that it was a duplicate where people had entered the same event twice in different time zones. And so you have to be, we have to be careful ourselves. We have to check ourselves and make sure that we don't pull earthquake stories that are based on false.
With that.
Yeah.
Almost did.
So there's a lot of that. It's fun in the sense storytelling as the main goal.
And then I think the other aspect of these maps, they serve so many purposes because we find the stories in them ourselves, but the stories are so easy to see when they're in an image. You can say like, look, there were foreshocks, and in the timeline, you can see the foreshocks, and people can ask questions, right? They can look at it and they don't just have to read what we say and trust us because it's right there in the image where we found the story ourselves.
Yeah.
So that's pretty, I think it's really fun to be part of that. And it's fun to imagine how people are using those images themselves to enhance their own understanding.
Well, I think equally effective graphics put together in these posts with these earthquakes is the narrative. Writing is just, it's clearly not AI. You guys are actually writing this. At least I hope I'm correct in that sense. That
you're extremely correct about that.
Yeah, and even to the point where this last one, and I think it was Judith writing, I'm assuming, but one on the Alaska earthquake that happened pretty recently, which occurred underneath the Hubbard Glacier, and then just there was a very witty stuff in there about like we addressed the most critical, important question first, and that is Hubbard Glacier related to Judith or something, some ancestor or whatever. And then there was a little kind of like little tangent on like, well, obviously you did a little ancestry research there in that moment to be related to who is the Hubbard Glacier name? They're related to this person, and but the humor and the levity in the narratives are just really nice. It just the whole thing flows really nice.
This is one of the things that earthquake communication really suffers from is nobody's very happy after an earthquake. You're not really usually like earthquakes that make the news, right? And that people care about because they've been affected by it. Usually there's not room for like levity or jokes or something. But when you write about so many earthquakes every year, there are ones like that don't affect people negatively. Not every earthquake is a disaster. It's a natural process, right? People call earthquakes a disaster. Well, I mean, a rainstorm is not a disaster, right? Like without it, we would, um, without plate tectonics, the Earth wouldn't be what it is. Life would be totally different. So when you write about a lot of earthquakes, you can choose the times when you can kind of go off script, and be more silly or more humorous and have fun with it. And then there are times where you really cannot do that, right? Like when people are impacted, and are suffering. Yeah, you got to be more matter of fact. You can be respectful of that. But well, we also, I think, if you read our stuff, you may have noticed we don't really focus on the suffering. We let the news organizations, we let other people who are closer to that talk about like the individual human stories of suffering or show pictures of damage. We don't show very many pictures of damage. Usually it's only if we're talking about a specific type of building. Um, but we don't plaster, falling down buildings and people trapped in our blog posts because, we feel like it's an element that's unnecessary for us, right? We will talk about damage, we'll talk about things in a matter of fact way, right?
Yeah,
Goal is not kind of like to focus on that.
yeah, I think you
Yeah.
guys are very quick to like, here's what we know, 1,000 fatalities so far. You give a few like those of, and you're quick to just go into why did this earthquake occur here, or how did this relate to the last earthquake. So the whole thing just flows so well, and it's they've just, I don't know, they're I think they're wonderful. And so hopefully, I think people that are interested in earthquakes, and I know there's a lot of people that want to learn from. I mean, some people will want the 3 minute or less, little news clip, video clip that shows, but there's an avenue for that. Right? There's a place to go get that if that's what you want. But if you really want to understand these on a deeper level, I feel like this is where your earthquake insights shine. So, well, let's maybe switch gears a little bit as we kind of wind down here. Maybe talk a little bit about some of the biggest fallacies or misconceptions about earthquakes, as you guys have maybe addressed people in the public and interacted with. Like, what are some things that are kind of out there that you just want to get the record set straight as best you can?
You get to take it.
Whoever wants to go first.
Well, I think there's one element that earthquake maps can be pretty misleading for people a lot of the time because an earthquake, especially as you get to larger earthquakes, are represented as dots on maps. So it's like the earthquake happened at this one single location. But for large earthquakes, the fault could be 100, 200, 300 miles long, right? And so the whole length of that fault is a place where people could be close to it, and you get these very large impacts as a result. And we often don't know what the fault was right away, right? We don't have that information. And so you don't see it in the early maps. You see a point. And people might wonder, for instance, after the earthquake in Myanmar this year, was it this year?
Yeah,
2025.
Yeah.
7.7 was like in March. Yeah.
If we're talking about how far away different locations were from the earthquake, but the fault that ruptured was something like 400 kilometers long.
Longer.
Or 500 kilometers long. And so you might have been 500 kilometers away from where the earthquake started and still be right next to the fault that slipped.
Right, and have surface rupture like we saw in that viral
exactly.
video.
Yeah. Yeah. I think people who are public facing about earthquakes always have to understand that many people in the public believe that earthquakes are in some ways predictable. And so that can range from kind of like a scientific vision that earthquakes may have a higher level of predictability than random to a very non-scientific vision that like my personal experiences or something unrelated happening in weather or animal behavior predict earthquakes. And this is a classic problem that people have had to wrestle with for centuries now, where after an earthquake happens, people look back at what they saw happening before the earthquake, and our human brain makes a connection between things. And so people will say I saw, a swarm of frogs migrating across the road, and then the earthquake happened the next day. This is a very well documented, but basically incredibly persistent style of thinking about earthquakes. And it's not just animals, it can be weather, it can be, um, I mean, these days there are conspiracy theories about government involvement, these kinds of things. So one of the biggest issues is that people attribute causality to earthquakes, right? Which we do not have evidence for. Earthquakes, they're not random, right? As far as we know, they're not random in time, but they're very close to random in time. So we spend a fair amount of our time trying to make sure we don't inadvertently lend credence to these kinds of pseudoscientific, ideas. And of course, there are very broad fields where people have pretty entrenched ideas about what happens before an earthquake. That includes scientific disciplines to some degree as well. So we want to talk about it in a responsible way. And sometimes that means not talking about it at all, because there's almost no responsible way to talk about fringe conspiracy theories.
Right. So,
Yeah.
I mean, some of it kind of goes back to, I mean, the things you're saying there is the good old, correlation does not equal causation. Just because some two events matched up in time or in space or both doesn't mean that they were linked, influencing the other. The one thing I hear a lot about now, and maybe you can speak to this if you want to, is just the effects of like space weather, some link between, cosmic solar particles in space, and that's a triggering mechanism for earthquake. Do you guys have anything you want to speak to about that?
Yeah. So in the end, it doesn't matter what phenomenon you want to talk about, whether it's cosmic rays, whether it's tides, whether it's something else. In the end, well, tides, okay, but unless you have like an actual measurement that relates the phenomenon you're talking about to the nucleation and propagation of an earthquake, then what you're going to have to rely on is some kind of statistical correlation. And the problem with all of these fields is that they fail to be rigorous in their statistical assessments. It's almost always like we looked at this and two earthquakes showed this. Well, two earthquakes can show anything, right? Low sample numbers plague these kinds of things, largely because the proponents of these models or these ideas will ignore everything and focus on the few examples that they think supports their case. It's general across basically all of these proposed mechanisms. It's very difficult.
Selective bias, would you say, basically?
Yeah, exactly.
Yeah,
Yeah.
there's so many earthquakes every year, right? There's I don't know, dozens of magnitude seven pluses a year, and then you multiply it by basically 10 every time you go down a magnitude. So that would be hundreds of magnitude sixes and thousands of magnitude fives and tens of thousands of magnitude fours. And when you have that many earthquakes, it's easy if you want to show, right, that earthquakes are related to some phenomenon. You can find some that happened after any phenomenon. You could find some that are related to like certain sports teams winning events.
Right.
You could find some that are related to the percentage of cloud in the sky. You could find some that are related to like school graduation. And it doesn't mean anything, right? There's no reason to attribute any meaning to that number. But we see people do that. And they aren't always doing it because they want to trick people. I think they're often tricking themselves because they find reasons to justify why they've selected these earthquakes rather than other ones. These ones are the most impactful that they care about. These ones match the data. These three happened in the month of May. So, they're tricking themselves, and that's why I think they can come across as compelling because the people who are saying it believe it.
And then the other dynamic at play is people will propose these things, but they will never allow themselves to be made responsible for them. So they will never say, like, based on my model, the next time that this solar flare spikes like this, we will see a magnitude 6 earthquake, right? Nobody's ever, yeah, they're not allowed to hold themselves accountable. In fact, they often disclaim accountability in the future, but they claim, like that the past is fine, but that the future they're not responsible
Yeah, and
for.
that's a big part of science, right? It has to be it has to be a predictive tool if you're going to really like say that this mechanism related to the phenomenon, something you can like forward with, look in the rearview mirror.
Right.
What happened then, and so.
And the main problem with earthquakes, right? Of course, the origin point of an earthquake deep in the earth is inaccessible to us, right? We don't know like much about these locations. We can see surface examples of exhumed faults. We can make good assumptions about some things, but in the end, we don't have access to that. But every large earthquake starts as a very tiny earthquake. And every very tiny earthquake, except for a few, does not grow to be a large earthquake, right? Um, and so some people will say, I'm only interested in talking about the prediction of very large earthquakes. But if your mechanism only works on large earthquakes and not the 99.99999% of other earthquakes, what is different about this, right? If you can't point to something that's different, then there's a logical gap, right? It doesn't make any sense that you should only be able to predict the earthquakes that eventually grow to great size and not small. And the reason why there's only a few very large earthquakes. So if you want to kind of, there's 5 magnitude 9 plus earthquakes that have happened in, historical times. So, it's very easy to talk about the origins or causative factors of magnitude 9s. You only have 5 points to explain.
All days,
Um,
yeah.
Yeah, you drop it to 6s, suddenly you're in the tens of thousands, and your method doesn't even come close to working.
I mean, there's nobody who wants to understand how earthquakes work more than earthquake scientists. They put their whole career into understanding how earthquakes work. And if anybody in that field could point to something as simple as solar flares and say, look, what causes earthquakes. Look, you can see because every earthquake is preceded by a full solar flare. It would generate a lot of interest in the field because
Yeah.
all these scientists would be like, oh, you have figured out how earthquakes work. But unfortunately,
They've already moved on from that.
nobody moved on from it. That's why people don't study it anymore, is because it's clearly not why earthquakes work. So you won't see papers talking about how they do or don't because it's irrelevant. It's not productive.
You find that frustrating when, like, I think this has happened throughout for probably centuries, that there was could be the weather, like you said, or how animals behave or whatever. But it seems like we're just on to the newest thing that people want to associate with earthquakes. Is that because earthquakes still have this kind of mystical quality to them? They're underground. We can't see them. They're hard to study, and we want to make sense of our world. Is that inherent?
Yeah, I think people believe that things have causes, right? People, even for earthquakes, I think some earthquake scientists will even think of it this way for some earthquakes. They'll say this earthquake was caused by this, right? Like maybe this earthquake, let's take an aftershock of a large earthquake. So if you have a magnitude 8 earthquake, and then 2 days later you have a magnitude 7 earthquake, okay, in the same place. So it's not a big jump to say that this 7 was caused by the magnitude 8, but that's actually not true. The stress that caused the magnitude 7 was accumulated by, motion of the plates over a long period of time. The earthquake is just the straw that broke the camel's back, right? But there's many other causes that go into that single earthquake. It's not a So people look for singular causes because that's how we understand things as humans. We're very bad at saying, yes, this is an important cause, but it's not the only one. You can look at like public health, right? Like people will say, what's the cause of, like autism, right? Like people want a cause, right, for an effect. But many times there are many different causes. And the idea that you can disentangle these things in a system where you just can't observe what's happening directly, is pretty unlikely.
Right. Or you could look at somebody who gets lung cancer. You ask, well, were they a smoker? And if they weren't a smoker, then they're part of the background rate of people who get lung cancer for reasons we don't really know. If they were a smoker, it's because they were a smoker. But there's some number of people who get lung cancers who smoke cigarettes who would have gotten it anyway,
Right.
Yeah.
right?
Yeah,
You don't know.
we're
So
just not good at,
aftershocks are
yeah, it's like we're not good at dealing with situations where there's multiple variables. Like we're just not good at like, oh, there's like 20 factors probably at work here. But it makes so much more sense, so much easier if you just tell me there's one. Like smoking.
there can, yeah. There can be utility, right? It's useful to know that smoking increases your risk of lung cancer.
Yeah.
And it's useful to know that after a magnitude 9 earthquake, you're going to get a lot of aftershocks, right? So you don't have to always, talk about all the nitty-gritty and the details. You can say this was an aftershock. And it was. It's an aftershock. And, aftershocks are very likely to be related to a large earthquake, even if it's not every single one was caused by.
Right. So yeah, so I think a lot of these issues come back to just the fundamental human desire for a simple explanation for something that may not actually have a simple explanation. It may have a very complex, integrated cause. So can we combat this human kind of behavior? Yeah, we can, right? But it's not 100% clear how you make widespread progress on this.
There's a story that happened after the earthquakes in Turkey in 2023. There was a person who was claiming that earthquake and other earthquakes were caused by the alignment of planetary bodies.
Yep.
So like when Jupiter and Neptune align, and he had some plots that he would show. It's hard to know because it was never presented in a scientific way where you could go back and look at predictions and rates of earthquakes. There was no code provided, no algorithm provided. It was just sort of every day a new plot with some area highlighted. And so somebody in the scientific community said it's very frustrating to have this misinformation out there. Maybe somebody should do something about it. Maybe I should do something about it. And they wrote a paper about how they looked at all these alignments of planetary bodies and they showed there was no statistical correlation, and published it. And I believe that the person who was coming up with these original plots said, well, you did it wrong. I do it differently, right? My method is different from your method, and that's why mine works and yours doesn't. So he didn't change that person's mind. And I don't know how many people's minds were changed, right? Because scientific papers, scientists.
Yeah, I mean, just
so know where the effort is worthwhile.
Tackle these. It's not simple. I mean, it's complicated systems. Earthquakes are definitely complicated, and yet they impact us so profoundly when they're large magnitude and affect so many people. And I think that's maybe the kind of crux of what you guys are hoping to do, is just like gain just a little bit more insight and knowledge about scary or a little random and chaotic in the world. And I think people are really. What are some other things? Yeah, go ahead, Judith. Look like.
Yeah, I was going to say, when we were practicing academics, we would spend months and months and months looking at one specific event, right? So we aren't practicing academics anymore, but now we spend so much time looking at so many different events. It feels like we've gained an entirely new perspective on the range of earthquake behaviors that we didn't have when we were doing scientific research. And it feels really valuable to us. And that's one of the things we're hoping to share is give people that view into the range of behaviors, because as scientists, it's easy to fall into this trap of you look at one earthquake and you see the factors associated with that single earthquake and you want to draw causality. And now that we look at so many, we can say, okay, so in this event, this one thing happened, but that's just one event. And there's all these other cases that we've looked at now where that didn't happen. And so I think it's easier for us to not fall into the trap.
And this, there's a bigger conversation to be had about that. times have changed a lot. And so when we were, even a few years ago, a lot of departments had people in them who were seismologists who, the fossils of the department who dated back to before computers, right? Who had experienced many earthquakes over their career. And I don't know if you've ever known these people, they'll have like an encyclopedic memory of all of these different earthquakes that they analyzed or read about and they thought about very carefully. And they got to the point where they had this like grand knowledge that they could access, but other people can't access that. Now, as you like look at the way academia has moved, where students are incentivized to publish quickly and often to publish on very specialized subjects, but they're not really encouraged to develop broad backgrounds or read very broadly in their field. But they get rewarded for the technological leaps, the sudden little bursts. And there's this very good question about over the long term, how is this going to pan out? If there isn't this apprenticeship of background knowledge that occurs about earthquakes, and people end up in careers where they have, are hyper specialized, are they more likely to overinterpret, their particular result versus the corpus of events that have happened over the last century? How do you get that kind of knowledge? Well, you have to look at a lot of earthquakes. And um, the seismologists we meet, all basically, many of them will reminisce about the Seismolab at Caltech, which was often some mansion in Pasadena. And they had a basement, and people would go down during the day and look at seismograms together. They would bring them all out and talk about them, all these different earthquakes. And that experience of just really looking at every earthquake they could, I think carried on to a whole generation of seismologists. And many departments have tried to reproduce this specifically. They like will build a room and they'll have like an earthquake hour and they will try to do this.
Yeah.
Because they know that just looking at more and more earthquakes helps you gain the context for really understanding these things in a more holistic way. So hopefully what we're doing helps some people do that. I think we know that some groups now do like print out our posts and talk about them at coffee hour and stuff,
Yeah. Yeah.
which is good.
Yeah. It's
People should.
swinging back from the side of being so hyper specialized and just, rabbit hole with your head that you just else. I mean, you've spoken very nicely today about how doing the Substack has allowed you to gain a broader perspective. You guys were specifically looking at Greece and Asia for a while, Paul, and now you've like looked at all these earthquakes from various places, South Sandwich Islands and places you probably never even thought of before, and that's really added to your breadth of knowledge. Pass that on.
But that's not to undercut the great work that people do at the
Right. We need both levels, right? Yeah.
Yeah. It's a great time to be in the field in that sense. Like there's revolution going on right now. A lot of people are learning a lot. So it's not to undercut all the people doing all the important work, right?
And we get to, we get to discover some of that work as we're writing because, we need those scientific papers that are published in detail to support our. And it's often papers we never thought about because it's places we've never thought about. It's local geology studies where people put months or years of their time into learning something, and now we can just kind of hop in and take a peek. And so that's pretty great.
Yeah.
Well, this has been awesome. I really appreciate guys coming on today. Again, Earthquake Insights is the name of the Substack. We'll put a link under the thing. Anything else you want to share about either your newsletter or anything else that viewers might want to know about your work?
Hadn't thought of it.
Okay. They might be wondering about our foster kitten.
Oh, yes. We've been ignoring the cute kitty in there the whole time. Go ahead and introduce the kitty.
Yes, this is Rufus. He's living in our house temporarily as he grows a little bit and is ready to go out for adoption. So check in with your local animal shelters and see if they have a foster program. Ours covers all the vet care and all the food. So it's no cost and a great way to get some kittens in your house.
How old is Rufus?
Yeah.
He's about 10, 12 weeks, I think. He came to us pretty sick, so he needed some recovery time.
cute perched on Kyle's shoulder there for a little while. So,
Yeah.
well, hey, thanks so much. If you guys are open to it, it'd be fun to maybe circle back and have another conversation, down the road sometime, maybe on a specific earthquake or something, if there's something really insightful, and that would be cool just to maybe share something in a video format.
Yeah, we're excited to do all kinds of weird stuff because it's a brand new world, right? Like who knows what's interesting. Maybe we could do a live thing where we an event happens in your neighborhood.
Yeah.
And we get together and we go through the process and come up with something. I don't know.
No, that would be awesome. Yeah. Like we just think being open to just new techniques and just innovating and trying things and falling on your face. That's what.
Yeah.
Well, thanks
again.
for
having us on.
Yeah. Appreciate it. Okay. Thanks so much. We'll see you guys next time. Thanks.
Bye.